Hey guys, of course I have to throw you a curveball. I told you that not all polynomials are the same, and here is your spoiler alert. Not all polynomials can be factored. So if we follow our steps, the first thing that we should do with example 4 is we should look at the coefficients. I see that the first term has a coefficient of 5 and the second term has a coefficient of 13. So the factors of 5 is 1 times 5 because it's prime. The factors of 13 are 1 times 13 because it's also prime. So I can't take a number and factor it out of 5 and 13 because they only share a factor of 1. And if I divide 5 by 1, I'm going to be left with 5. So that doesn't do me any good. If I move on to the variable pieces, which are important, don't forget those. Just because the coefficients don't have a common factor, your variables might still have a common factor. But in this case, the first term has a variable of x and the second term has a variable of y. So those are not the same variable, so I also cannot factor the variables. This is considered to be a prime polynomial because I cannot factor anything out of it, not a coefficient and not out of the variable pieces. So it is in fact already considered to be factored, but it can now be labeled as a prime polynomial, just like if these were just numbers, 5 and 13, they're both prime numbers, so that's how we would label them. So not all polynomials can be factored, just keep that in mind. All right, moving down to example 5, I'm really excited. We've got some more things going on here. So let's start by just looking at the coefficients. The coefficients are the only thing that you need to take into consideration to start with. I'm trying to find a greatest common factor between 2, 2, and 4. Well, the greatest common factor between 2, 2, and 4 is 2. So I'm going to pull that out of each of the terms and see what is left behind. Now I'm going to move on to the variables. I have an x squared in the first term, an x in the second term, and an x in the third term. Because I only have an x in the second and third terms to take away, I can only take one x away. I don't have two x's in every single term to take away, so I just am going to take an x away. And then I look at the last term, which is y, and y squared and y. So in the first term, I have a y, in the second term, I have a y squared, and in the third term, I only have a y. Since the first and the third only have one y, I can only take away one of the y's because that's what they have in common, all three of them. So my greatest common factor sits outside the parentheses. It is 2xy. Now I'm going to go through and I'm going to divide 2 divided by 2, which is 1. I don't have to write that. X squared divided by x means I'm going to leave one of the x's behind. Y divided by y is 1, and I don't have to write that. Minus 2 divided by 2 is -1, so I don't have to write the 1. And then x divided by x is 1, don't have to write it. Y squared divided by y is y. And then I have +4 divided by 2 is 2. X divided by x is 1. Y divided by y is 1. So here you have factored your polynomial. That is your final answer, which means you've rewritten it as a multiplication problem between two parts, separate pieces. And if I wanted to use that multiplication with the distributive property, I should be able to get back to what I started with. And you can go ahead and check your work. It's a really good idea to go and make sure you're checking through these. So here's your final answer for example 5. It's your turn to give some of these a shot. So I have some delta math for you to do. If you look on the next slide, it tells you exactly what delta math you need to do because it's your turn to get a little bit of practice in. It's going to be awesome. So good luck and hit me up during office hours if you come across a question about this. This is called factoring polynomials, which is the reverse of the distributive property.